An estimated 2 billion people worldwide live in areas that lack proper solid waste management systems. Inadequate waste systems present serious risks to human health and the environment. The United States Environmental Protection Agency's Best Practices Guide for Solid Waste Management and accompanying learning modules present best practices for solid waste management in developing countries. This video builds on 2 sections in the guide, understanding the need for solid waste management and approaches, and provides more detail on the impacts of solid waste and the benefits of improving waste management. Solid waste management systems are designed to improve health, environmental, and economic conditions in cities worldwide. Improper handling of waste can impact human health in a variety of ways. Organic and solid waste attracts animals, insects, and mosquitoes that can be vectors for diseases such as malaria, dengue, and the Zika virus. Mismanagement of waste and dump sites can lead to contamination of drinking water, and uncontrolled burning of waste can result in emissions of air pollutants that can be toxic for human health. Inadequate control of leachate, or water that enters disposal sites and draws out chemicals and other contaminants as it filters through the waste, can lead to the contamination of soils, water bodies, and impact local ecosystems. Mismanaged waste is a threat to wildlife, as animals and insects may consume waste that contains food residue or scraps. The burning of waste at disposal sites has a significant impact on air quality and releases methane gas, which contributes to climate change. Inadequate solid waste management can be costly through direct expenses and indirect costs. Programs reducing waste can lead to direct cost savings in transportation and fuel costs. Improved solid waste management can benefit human health, particularly for highly vulnerable populations, and provide cost savings on public health systems by reducing the risk of health concerns associated with mismanaged wastes. For example, waste that collects in streets may attract vermin that carry diseases, while practices such as open burning release air pollutants and can cause or exacerbate respiratory diseases. Cities recognize the many health, environmental, and social concerns associated with inadequate solid waste management. However, cities face many challenges in properly managing this waste, including limited financial resources and capacity, limited access to and technical knowledge of equipment, limited technical expertise and awareness of best practices, limited staffing and bandwidth to support solid waste management, political turnover, lack of planning and evaluation, lack of infrastructure, limited available land, cultural norms, such as increased generation of waste as cities grow, and the material consumption increases with economic status. Additionally, cities must consider existing community attitudes toward separation of waste, open burning, or recycling when developing solid waste management programs. Due to these challenges, no single solid waste management approach works across all situations. Governments should work to create a plan that meets the specific needs and conditions of their area. This waste management hierarchy provides a general ranking system for solid waste management strategies from most to least environmentally and socioeconomically preferable, and places emphasis on reducing, reusing, and recycling. The first and most preferred step in the hierarchy is source reduction and reuse. This solution focuses on preventing waste from being generated. When fewer raw materials are needed, less waste needs to be collected, transported, and disposed of, ultimately leading to less waste entering the environment. For example, individuals can seek out products that are reusable and long-lasting. Source reduction and reuse is the most economically cost-effective step in the hierarchy and leads to both environmental and human health benefits. For waste that cannot be reduced or reused at the source, recycling or composting is the next best option. However, this solid waste management strategy requires upfront investment costs to implement effective recycling or composting programs. Energy recovery converts non-recyclable materials into usable heat, electricity, or fuel, and reduces the amount of waste that ultimately ends up in landfills and dump sites, which offsets the need for fossil fuel use. However, this solid waste management strategy can require significant investment and operational costs. And if the proper environmental management protocols and infrastructure, such as emissions control equipment, are not in place, energy recovery can result in air pollution emissions. Prior to disposal, treatments such as shredding, incineration, or biological treatments can help reduce the volume and toxicity of waste. Waste that cannot be prevented or recycled should be disposed of in a properly designed, constructed, and managed landfill. Decomposing waste produces methane gas that can be collected and used to generate energy. Additionally, the land may be used for other purposes like recreational sites once it is capped properly. Understanding the impacts of solid waste and the waste management hierarchy is a key component of solid waste management for any city around the world. Visit the EPA's Best Practices Guide for more information. The guide is part of EPA's Solid Waste Management Toolkit. Scan this QR code for more information. Thanks for watching.